This is Russ Andersson. This is an Adobe stock shot that is typical for customers from helicopters and from drones these days when you want to insert a building or a new bridge or road into an existing piece of footage. And it's typical to have vehicles and people moving around in the scene, and you can't have any trackers on those in order to get a successful, accurate solve. So SynthEyes 1806 has a new tool to help you find those automatically. It's called Find Erratic Trackers, and it's a statistical tool that takes a quick initial look at it without solving the entire scene. It works just from the tracker data. So we're going to start out doing the tracking, and on this particular scene, SynthEyes tries to avoid putting trackers on moving objects in the first place. So what we're going to do is make things a little more interesting for it just by running up the number of trackers to increase the chances that those will wind up on the moving objects. So we've just updated those parameters a little bit, and now we'll run the auto tracker. So you can play through the shot and you can see, back here that there are definitely some moving trackers up there that we need to get rid of. And of course it could be a much longer shot, and the longer it is, the harder it is to find them all. So we're going to fire up the Find Erratic Trackers tool. You'll see it here on the track menu. It also is a script, so it'll show up on the script menu as well. So there are a fair number of parameters, and we'll talk about those a little bit later. But for now, we're just going to take the default settings. We're going to run the tool, get some output that we'll talk about later too. And we'll just take a look at what we've got. And you'll see that the tool has gone and selected a bunch of trackers that it has identified as moving. And, as you scrub through the shot, you'll notice that there are, a bunch that it has noticed up here. And there are a couple that it has not. And like I said, this is a statistical sort of process. And some of these, when they're relatively short-lived, they're not around long enough to really become inconsistent. This tool is looking for something that doesn't exhibit a perspective shift over the length of time that it's around. So short-lived trackers, turn out to have some valid 3D location, but it's often, far underground, off in the distance somewhere, something like that. So it's not going to find all of them. And you'll notice also that it has tagged a bunch in the foreground here that are not, erratic trackers either. So we have both some false positives here and some false negatives, and we'll see why this happens later as well. So at this point, you have two choices. You can either go and delete all of these, or you can go through and sort through and see which of them you want to keep, which you don't. And you'll notice that if I just unselect them all, you'll see that the Find Erratic Trackers tool has set the color of the trackers that it found to make it easier for you to go and identify them as you're going around and looking at them. I'm just going to undo that so that they're all selected again, and we'll hit delete. Similarly, we'll delete some of the other ones, and just to show on the tracker tool, if you turn on the delete button there, you get into a delete mode. It lets you just kind of blast away at things. So having done that, we can go and do this. I'll point that there's actually were some trackers on that truck for that matter also. If you notice. But we're ready to go and solve now. So let's fire that up. You notice that it is actually doing a bunch of work here. And wound up with a pretty high error, almost 2 pixels there. And if you think about this, you might guess what the issue is. That, in fact, we'll open up the lens distortion tool, and we'll just turn on the quadratic distortion and hit refine. Now you see it's dropped down under a 0.5 pixel of error. So, that's telling you why those trackers here by the overpass initially got some false positives on them. Of course, they're gone by now. But the point is that the trackers that were in that location were sweeping right along the edge of the image with a relatively high degree of error. So consequently, they wound up, not matching up with this find erratic tracker process, because the find erratic trackers process, like I said, it's not solving the scene. It's not accounting for any lens distortion. So if there is distortion, then it looks like the trackers are bad instead. So that is why they wound up on the short end of the stick there. So at this point, we've got our solve. We could go and turn on some additional distortion terms if we wanted, which would drop the error a little bit lower. But, normally what you do now is go and do some tracker cleanup, just in the conventional fashion. You can see that there are definitely some trackers around that do some strange things. We've got a lot of underbrush out there. So some of these are probably jumping from one little shrub to the next, something like that. So you do a little traditional cleanup work on the solved, and then you'd be ready to insert your new building here, say. Maybe we're getting a new warehouse here or something. One thing just to point out that people get into a little confusion with at this stage with inserting buildings is that you have the same questions that you do if you're building the real building, which is, where are we going to put the thing? And, the guys that go out there with backhoes and stuff, they're not just going to say, oh, this looks good, let's dig and put it here. They're going to do a little surveying and check some GPS references to decide where to go it and put it. So you need to be doing the same thing to locate your building into the scene. So that means, you need to have some reference points for which you have the ground truth, which could be some of the signs on the side of the road, or, maybe some cones that were put out in the plot of land. One way or another, you need to locate some things that you can identify the coordinates of and be able to, match those up into the blueprints and 3D model for the building that you want to add, so that, you're putting it into the scene at the place where it really is supposed to go. At this point, let's go and just roll back, and we're going to run that script again, the find erratic trackers, and just look at the different parameters. So, these are discussed at length in the manual. There is a section on this find erratic trackers, and a section in the reference part of the manual as well. So you can go and look at the tooltips on them as well as the reference material. The general idea, though, is that it's going to go and pick out a bunch of trackers in the frame at random and use them to kind of predict where the other trackers might be. And it does that at different pairs of frames at any various spots. So, from one frame, it'll look at a couple of trackers, and then it'll go to another frame and look at where those trackers are in that same kernel. It's the trackers that you're going to use for reference. And based on how those have changed, you predict where all the rest of the trackers have gone that are present on both of the frames. And if trackers aren't sticking with the program, if you like, if they're changing in a way that is unexpected, then you label it as possibly bad. And this process goes and accumulates how often trackers show up on the naughty list there. And if they're naughty too often, out they go. They're labeled as being erratic. So that's what these kernel size numbers are. Not only does it do that process for just one set of kernel trackers, but it's for each pair of frames. It's doing it with a whole bunch of different kernels that are all randomly selected, so that in case one of the kernels or a couple of the kernels actually have some moving trackers as part of the kernel, that would screw everything up. You eliminate that. So the kernel has to be able to predict itself. It has to be internally consistent. And you have a bunch of different kernels to try to make sure that you're getting ones that are really well set up. So you have different numbers on how accurate the kernel has to be, and then on how accurately you have to be able to predict where trackers are. And that's this number here. It's actually fairly high. So we're looking, kind of letting some stuff slide, and letting stuff slide a bit is appropriate when you've got a bit of lens distortion. But just for kicks here, we'll run in some different numbers. The frame step is, like I said, it's doing different pairs of frames, and it doesn't do all the possible frames or combinations, but operates kind of on a gridish sort of scheme, so we can make the grid finer to look a little harder. The shot's really long, then you want to have the frame step a bit larger. Can't be too large though, or the trackers, will be larger than the lifetime of the trackers. And we can go with more trackers in the kernel, so that'll kind of make sure that the kernel part of it is doing a better job of predicting. And we can try, more kernels, so we're, again, making sure that we get more robust, higher chance of having good kernels. We can make the accuracy a little higher. So, we can just run it again. And you get a fairly extensive set of output from this. Like a lot of things in the SynthEyes, the idea is that if you just push the button, you're apt to have, the default settings are going to be pretty good. Similarly, a bunch of the output, you can look, and it's just worth understanding what kind of the highlights are there, and if you want to dig in some more, you can do so. So, here it's telling you how many bad trackers there are, how many trackers had to be in common between the pairs of frames that it's looking at to be able to come up with an answer. Average travel of 234 frames has to do with how long your trackers are typically alive, and ties into that 21 trackers common number. The bad kernels number is telling you what of the kernels that it's tried, how many of those were bad. They weren't internally consistent enough. So 7.8%, 5 to 10% of the time, the kernels weren't doing too well at predicting, how well they predict each other internally. So that's a little on the higher side. That one accuracy number, for the kernel accuracy number, we could increase that number a little bit to let more of these kernels be good. Not necessarily a good idea, But this all depends on how noisy your scene is, how much distortion there is. If that number was really high, that would tell you really that the tracker data is too noisy to be doing this. Likewise, if it's very low, you might require that the kernel be better. This histogram here is giving a representation of how often a given tracker shows up as being good or bad. And the number in brackets is how many times that occurred. And the one bad kernel percentage number is the threshold at which point we decide that the tracker is bad. When the shots are really clean, the behavior you get actually is you get much larger numbers at the bottom. Then you get some low numbers, zeros, ones maybe in the middle, and then the higher numbers up at the top again. And you're looking to adjust that bad kernel percentage into that little trough in the middle. Here what you're seeing is the numbers are still trending downwards, and then they kind of plateau out a bit. The 15 has 11 times that happened. So it's saying we might increase the bad kernel percentage a bit higher, and that would cut down the number of false positives out here a little bit were we to do that. But you'll see from all this we've got, we might have picked up another tracker or two out there just by futzing with the parameters. But, like a lot of things here, the idea is we try and get values that are reasonably good to start with. And, if you're playing around with the parameters too much to see what works best, maybe you should really just be looking to see if there are a couple of bad trackers that you can take out in the first place. So that was just kind of give you a little insight into what's going on and what the issues are. It's time to recap the limitations of the Find Erratic Trackers tool. We're not going to be finding bad trackers that are very short-lived because they tend to come out as self-consistent points that are too far away or underground. You'll need to find short-lived bad trackers manually or eliminate them after solving. Fortunately, they don't affect the solve very much. If you have lens distortion, you're going to have to set the thresholds quite high to avoid false positives, and you're only going to find the worst trackers. Similarly, if you have a lot of rolling shutter in the shot, it cannot be accommodated by this tool. Even though the tool is designed to work on 360 VR shots also, current 360 VR cameras generally don't have the consistency and predictability required. A single 360 VR camera usually consists of from 2 to 12 conventional cameras, each of which has a rolling shutter, causing different sections of the final 360 VR image to shift around independently. Hopefully, for shots that are suitable, this tool will help you more quickly eliminate bad trackers and even locate some you hadn't noticed. Mathematically, it can't be perfect, but if it helps save time and improve accuracy, that's great. Thanks for watching.